Submarines are fascinating underwater vessels designed for navigation beneath the surface of water, primarily used in military operations, research, and exploration. Their history dates back to the early 17th century, but significant advancements have been made in design and technology over the centuries. To understand how submarines work, it is essential to explore their components, operational principles, types, and the various technologies that enable their functionality. The concept of submersible vessels originated in the 1600s, with early designs that were primarily experimental. However, it wasn't until the 19th century that the technology began to evolve significantly. The first notable submarine was the Nautilus, designed by David Bushnell during the American Revolution. It was a hand-powered vessel intended to attach explosives to enemy ships. Although it was not successful in its military endeavors, it laid the groundwork for future submarine designs. As we moved into the 19th century, several inventors and engineers contributed to the development of more effective submarines. One of the most significant advancements came from the design of the Resurgam by Reverend George Garrett in the 1870s. This submarine was powered by a steam engine and was intended to attack enemy ships. It demonstrated the potential of submarines in warfare, although it faced many challenges, such as the limitations of propulsion and buoyancy control. The most notable submarine of the 19th century was the H.L. Hunley, which became the first combat submarine to sink an enemy warship during the American Civil War. Built in 1863, the Hunley was a hand-powered vessel that used a torpedo attached to a spar to attack the USS Housatonic. While it successfully sank its target, the Hunley itself was lost, emphasizing the dangers associated with early submarine technology. Submarines operate on the principles of buoyancy and pressure. The key to their ability to dive and surface lies in their ballast systems. A submarine has a series of ballast tanks that can be filled with water to increase weight and allow the vessel to sink. Conversely, when the submarine needs to surface, compressed air is used to expel the water from these tanks, reducing the weight and allowing the submarine to rise to the surface. The basic structure of a submarine consists of a pressure hull, which is the inner section designed to withstand the immense pressure of deep water, and a lighter outer hull. The pressure hull is usually cylindrical, providing strength and stability. The space between the two hulls is often filled with air or other materials to improve buoyancy. The propulsion of a submarine is another critical aspect of its design. Early submarines relied on human power or steam engines, but the advent of electricity revolutionized submarine propulsion. Modern submarines typically use either diesel-electric or nuclear power. Diesel-electric submarines use diesel engines to generate electricity, which powers electric motors that drive the propeller. Nuclear submarines, on the other hand, use nuclear reactors to produce heat, which is then converted into mechanical energy to drive the propellers. Steering and maneuvering a submarine is achieved through the use of control surfaces, including rudders and dive planes. Rudders are located at the stern and control the direction of the submarine, while dive planes are positioned on the bow and stern to help control the ascent and descent. By adjusting the angle of these control surfaces, submarines can maneuver effectively in 3 dimensions, allowing them to navigate through underwater environments. One of the most remarkable features of submarines is their ability to remain submerged for extended periods. This capability is essential for military submarines, which often operate covertly. The air supply for crew members is managed through a combination of oxygen tanks and a process called electrolysis, where water is split into hydrogen and oxygen. Carbon dioxide produced by the crew is removed using scrubbers, maintaining a breathable atmosphere within the submarine. Submarines also come equipped with advanced sonar systems, which allow them to navigate and detect other vessels in the water. Sonar works by emitting sound waves that bounce off objects in the water, providing information about their location and distance. There are 2 primary types of sonar, active and passive. Active sonar sends out sound waves and listens for echoes, while passive sonar simply listens for sounds made by other vessels. This technology is crucial for submarines, as it enables them to avoid detection while gathering intelligence. The modern era of submarine warfare has introduced a variety of specialized submarines tailored for specific missions. Attack submarines are designed to engage enemy vessels and carry torpedoes and missiles. These submarines are typically fast and maneuverable, capable of operating in hostile waters. Ballistic missile submarines, on the other hand, serve a strategic role in nuclear deterrence. They carry intercontinental ballistic missiles, ICBMs, and are designed to operate undetected for long periods, ensuring a retaliatory strike capability in case of a nuclear conflict. Research submarines are used for scientific exploration, allowing scientists to study marine life, underwater geology, and other phenomena. These vessels are often equipped with specialized equipment such as robotic arms and submersibles to gather samples and conduct experiments at depths that would be impossible for human divers. The technological advancements in submarine design have not been without challenges and controversies. The development of nuclear-powered submarines has raised concerns regarding safety, particularly in the event of accidents or nuclear leaks. The potential for environmental damage due to accidents or the disposal of nuclear waste has led to ongoing debates about the use of such vessels. In addition to their military and research applications, submarines have played a crucial role in environmental monitoring and exploration. Oceanographers use research submarines to gather data on climate change, underwater ecosystems, and geological formations. These vessels have contributed significantly to our understanding of the oceans and their vital role in the Earth's climate system. Submarines also have a unique place in popular culture, often depicted in literature, film, and video games. From classic novels like Jules Verne's 20,000 Leagues Under the Sea to modern action films, submarines have captured the public's imagination as symbols of adventure, mystery, and technological prowess.